Hello everyone, in today's video we will be talking about angles, and this will be a review of things that we talked about last year uh, so that you can remember them. We're going to begin by talking about angles. Firstly, we will be redefining what angles are. Angles are created when two lines intersect, so when two lines meet. So here, for example, I'm going to make two lines. And you can see that these two lines are meeting at this exact point. At this point, they are creating an angle. That angle is defined as this little corner right here. Whether it's big or small depends on, imagine that there's the hand of a clock, like the line that I'm moving right now, and starting from one line, I'm just trying to get to the other line, right? Trying to make this sweeping motion. How big of a motion it needs to make to get from one line to the other shows how big or small that angle is. We measure angles in degrees using a tool that is called a protractor. And you can see the protractor right here. A reminder of how this tool works. How we use it is we take it and we move it so that the center of it, so you can see the center of it right here, we need to place it on the point where the lines meet, so right there. And then, now I've placed it correctly right now, but let's say that it wasn't placed correctly. Let's say that it was placed like this. Oh, well, shouldn't have done that. Let's say that it was placed like this. No, we can't have it like that. We need to have one of the sides of the protractor, so either this side or this side. We need to have them, one of them, touching one of the sides of the angle. So, for example, it's either going to be like this, like I had it in the beginning, or it's going to be like this. I can find the angle with both ways, but I'm going to prefer doing it like this so that I don't have to read the numbers upside down. And how do I read this? How do I read how many degrees this angle is? I do that because you can see here that most protractors, what they have is two sets of numbers. They have the outside set and they have the inside set. So you might think, okay, but which one do I use? Well, here's how we think about that. Consider that this right here is the hand of the clock that we were talking about before that needs to start from one side and get to the other. Well, imagine that it's starting from the side of the angle that is touching the protractor, right? So here. It's not starting from here, which is inside of the protractor. It's starting from here, which is on the edge of the protractor. Well, on which set of numbers do you find a 0 right here? On this set, the outside, or on the inside? Well, there's a 0 right here. So we're going to start by using this set, the inside set. We're going to say that the angle is 0, 10, 20, and not 30 really, a little bit before that. So let's see, where exactly? It's one line before 30, so we would say it's 29 degrees, right? Now let's create another angle for us to measure so that we can get another example. I'm going to make it a big angle this time. So you can see that it's really wide, it's really open. Now let's take our protractor. Again, we place it so that its center is exactly on the point where the lines intersect. And I will try to do this as best as I can. There we go. And then we need to rotate it so that one of the sides of the protractor falls on one of the sides of the angle. So either like this or like this. You might think, well, okay, but why not like this? Here, now it's touching it, right? Or what about this? Well, yeah, both sides are touching in this case, but what you might notice is that the other line here, this line, is outside of the protractor. So I can't really measure anything by having my protractor in this position, can I? And the same goes for this case. You can see that my protractor is touching one line, but the other line is outside of the protractor, so I can't really measure anything like that here. I usually place the right side of the protractor on the um, on the angle, so that I don't usually have to get confused on which set of numbers I use. Because if you always place the right side, if you always place your protractor in such a way that the right side is touching one of the sides of the angles, then you're always going to start from this set, from this zero, so the inside set of numbers. So again, we're going to imagine that we have the hand of the clock here, right? Now we want to measure how far is it to get from this side all the way to this side. So we start off from 0. 0 is here on the inside set again. We're going to go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, and then a little further than that, it seems to go to the third line from 130. So I would say that this angle is 133 degrees. But just to show you that it doesn't really matter which side of the protractor I chose to place, I am going to change its position and make it so that the other side is touching. And you'll see it's still going to be 133 degrees. Oh, maybe did it move a little bit? Yeah, it seems like it moved a little bit. There we go. So again, we have the hand of the clock that is now starting from this side because this is the side of the angle that is touching the protractor and it needs to get to this side. So now we're going to start from this 0, so the outside set of numbers. So we're going to say 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 133 degrees, just like before. So it really does not matter which side you choose to start measuring from. Okay, so that's how I use my protractor. Now I would like for us to discuss the different types of angles. I have 3 basic types of angles that I usually see in geometry. The first one is this, And I'll explain what they are, what each of them is later. The second one is this, which you might already recognize. And the third one is this. What you notice about them is that this seems pretty closed. This seems pretty familiar. You might even remember what we call it. And this is more open. What certainly happens is that as we start from here and move towards the right, then the angle opens, right? Becomes more open. All right, so you might remember that this angle, one that forms a perfect L shape, is called a right angle. This angle, if you take the protractor and measure it, is always going to be 90 degrees. In Greek, it's orthogonia. It is symbolized when we want to show that an angle is a right angle. We make a little square right here. So you may have seen angles like this, where we show the angles like this, for example. Sorry. So it's almost like part of a circle, and the same goes for other angles. Again, like it's part of a circle, but only for right angles do we use this square, because we want to show that this is a right angle. Now what's going on here is that this is less than a right angle. It's smaller. It's less than 90 degrees. And angles like this are called acute. Angles, or in Greek, oxias gonias. Actually, we're going to write it in singular, oxia gonia. And this angle is more than 90 degrees. Angles that are more than 90 degrees, that are more open than 90 degrees, are called obtuse. So this is an obtuse angle. And in Greek, that would be amblia. There are other types of angles. So we have, for example, if it's a straight line, right? But we break it up into two pieces. So imagine that this was actually two lines that connected at a certain point. Let's say they're connected here. You might ask, okay, well, if this is one part and this is another part, then how many degrees is it to start from here and then go all the way around like a clock again, like the hand of a clock, get here? How much is this? That is 180 degrees. And this angle is called straight, because, as you can see, it's made up of a straight line. In Greek, that would be thea. Great. Lastly, what if one line, I have one line, then I have another line that falls exactly on the previous line, right? And let's say someone asks, okay, well, how many degrees is it to start from here, right, like the hand of a clock, and then make a full rotation all the way, make the entire circle and get right back to where you started. That, as we said, is a full rotation. And that's what this angle is called. And it is 360 degrees. In Greek, it's plidis. And again, as we said, this is 360 degrees to start from one line and then make the full rotation back to where you started. And here, half that way is the half of 360, 180. So those are my types of angles. We're mainly going to focus on those three. You're not really going to see a whole lot of these, but you do need to know that straight line has an angle of 180 degrees and a full rotation is 360 degrees. But mainly we're going to focus on these three. Well, tomorrow we will be seeing how these types of angles affect triangles and how we use them. So I will be seeing you again in tomorrow's video. Bye.